And while I was, and one of the things I emphasized during that presentation is the need to, that was a kit. No, that was not a kit. This is a kit. That was where I had a bill of materials provided and followed that bill of materials, ordering all the parts. And I wanted to stress in that presentation how important it was to be sure before you jump into a project that you're able to acquire all the parts. And I had an example that is based on a Raspberry Pi 4. And last week, I got an email from Newark, and it said, your order is ready to ship. And I thought it was a scam at first, but I had forgotten I'd ordered a Raspberry Pi 4 in April of 2022. And I got it last week. So that's how important it is to, because that could stop you if you have something and you can't get something, that's going to stop the project. Talking about that a little bit, I understand the CEO of the Pi Foundation said that let's see, I shouldn't be, well, let me check this. The 2023 is still a recovery year. He didn't feel that they would be able to overcome all the bottlenecks in manufacturing until the third or fourth quarter of 2023. So it won't be until 2024 that the Pi Foundation, those guys and their products will be able to, produce without these constraints. We've experienced in the last, since COVID. So parts availability is important. But tonight we're talking about a kit and all the benefits of a kit. All the parts are there. It's well documented. I have an operator's manual, instruction manual. And even there's a YouTube video to help with some of the assembly and critical parts from the assembly. So this is a amplifier. And have you noticed how many people are offering small, well, physically small size amplifiers, LDMOS or MOSFET amplifiers, that just a proliferation of those? It's even more and more. I noticed it because I'm working with the Hermes, Anon radios, the SDRs. You're searching those terms and you would get some connections with folks in Russia. This is prior to the war in Ukraine, or some of the guys, engineers in Ukraine, offering some of those boards. And not just the amplifier board, but sometimes with semiconductors, without semiconductors, or with heat sinks, with bandpass filter boards. You could buy a bandpass filter board to connect with it, a controller, protection boards. But I didn't see a way, wasn't a clear path to put all the parts together. And so through the IO group of the Hermes Light 2, somebody mentioned this RARC 500 amplifier, and it's a kit, and it's all, you got all the parts there. You can see it to completion. And it's Hobby PC's manufacturer, and they produce the RARC 50 amplifier. And so some of you may have, be aware of that amplifier. It's been around for at least like 10, 15 years. They've got a really good reputation. So I was pretty, comfortable jumping into it, and I've had it a couple of years. And so to give you a little tour, you'll have the front interface. That's an Arduino controllers up there. That'll give you the status, give you the band you're on, give you forward reflected power, tell you what mode, what band. You can choose antennas. You can have 2 antennas connected to it, so that that's all the information what's going on with that with the amplifier. The back, you'll have the interface, the antenna inputs. You'll have an accessory connector there for giving it band information. So I could follow the RARC 50 information from the SDR, my SDR transceiver, and it would automatically follow that to change bands. And USB port, transceiver port, push to talk, power, 110 volt power. The power supplies, switching power supplies, there's no heavy transformers. These are Meanwell power supplies. They're commercial power supplies, pretty popular. Each one of those is 16 volts. And I believe they're 10 or 15 amp power supplies. And then there's this one power supply covers a variety of 3.3, 5 volts, and 24 volts. On the top, we have the bandpass filter on this side, and here's the amplifier, actually, just this one board. So all of this is just support for the one board with it.
Push-pull.
Yes, push-pull. And you'll notice there are just two semiconductors here in the whole thing. There are no drivers, no buffers, no, it's just these two MOSFETs that are responsible for all that gain. This is 500 watt, but it's 5 volts in, 500 watts out. So we want to talk about look at that. How's that possible? That technology. So we can. Any questions about the tour, and the construction?
I see some toroids up there. If you have to wind those.
Yeah, winding toroids. So I assembled this board and this board. The control boards were already pre-built, and the Arduino program was already loaded. And then there's a nice YouTube video on making up the wiring harnesses. We normally don't series connect all of our power supplies, and they wanted to lead people through that process of getting the 3 power supplies linked up in series to give them 48 volts. This isn't this amplifier is not running off of the typical 13.8 volts that we would have on our base rigs. It's the amplifier is running off of 48 volts, and that's necessary because of the MOSFET technology.
Considering the amount of gain that amplifier had, what did the FCC require?
So I'll get to the FCC at the latter part. We'll talk about the fact that I have that. It's possible for me to own and operate that because normally ICOM can't sell them. Kenwood couldn't sell this, but I could buy it from Hobby PC as a kit, as actually 2 kits. He supplies the support kit for the amplifier, the RF power tool. So you have Hobby PC is providing the support kit, and the other company is RF Power Tools, and they're responsible for the design of the actual board with the MOSFETs. So you get 2 kits. But let me go into that a little bit later. So how are we getting that gain? And so it's what we have, or what we're working with is MOSFET technology rather than a bipolar transistors. And if we think about how does this work? So it's like a FET. You start out with a FET transistor. So you have a source, a gate, and drain. In a MOSFET, you want to have, it's a metal, the MOSFET stands metal oxide field effect transistor. So you're going to have an oxide layer, and you're going to have a metal layer for your gate. And you have this substrate section here. And as you apply a positive potential here, it's not really a current. It's one of the ways where we don't need other drivers or pre-drivers. We're not really drawing any current here. So you have a static potential, negligible. If there is current, it's negligible. So you're going to have, as you increase and reach the threshold for conductivity, you're going to influence this channel region, and you're going to have a flow across here from your source to drain in this channel region. So you have a substrate, a depletion layer that when you reach this potential here, you'll have a current flow. And with a very low resistance.
Did somebody have a question? Was someone trying to ask a question? Nothing heard.
So the MOSFET and I can go down here and we talk about another. You'll also hear about LDMOS. LDMOS is LD will stand for lateral dispersion MOS. They don't put the FET on that. In lateral dispersion MOS, what is happening there? The dispersion is you're separating these two, your source and drain, physically separating them, and you want to have a little bit different region here. It's not shown here, but you'll have a drift region. It's called a drift region in here for that to start working. So that that'll give you, and that what they're doing is they're increasing the voltage, increasing the you're still in some hundreds of volts. You're not, when I talk about higher voltages, I'm not talking about thousands of volts. You're talking about, maybe a few hundred volts. But to do that, you'll see the LDMOS used. That's when they're usually, you'll find that amplifiers built around the LDMOS design. This one is just a MOSFETs. Yeah.
Do you think the big difference between those is the breakdown voltage between the LDMOS and the regular MOSFET?
Not the breakdown voltage. It's it's this voltage across the source and the drain.
Just the voltage level is something different.
Right. Across the device. So we'll spend, and I, spending a little time here with the device, because that's, that's where the magic is. So it's, here's some of the features of this. It's what's being used here is a VRF 2933. This is what it looks like. This is what's installed onto the heat spreader. It's typically 33 watts, 300 watts with 22, based on 22 dB a gain at 30 megahertz and 50 volts. So what is 20 dB a gain? If you had a 10 dB of gain, that would be equivalent to a 10-fold increase. So if you put in 10 watts, 10 dB a gain, it'll be a 100-watt amplifier. If you had that same 10 watts and put it into an amplifier that had 20 watts, 20 dB a gain, that has a 100-fold equivalent. So if you put in 10 watts and you have a 100-fold, that would be 1,000 watts. So that's the kind of gain, that's where we're getting this ability to achieve the output. Looking further down in some of the specifications that appear, the operating junction temperature 200 degrees C. So that's so we talk about back to the construction. I'm gonna give the camera guy a workout. So now I've seen, my experience is most of the transistors are attached to the heat sink, but here the transistors are attached to a copper heat spreader. And then the heat spreader is attached to the heat sink. And then you'll see fans running down the fins of the heat sink. And then they have a separate fan in the back, just one larger fan cooling the power supplies. So getting that heat away is real important. If you're talking about 200 degrees, if you're pushing it that far to 200 degrees C. What else? But when we talk about power, that's a single transistor at 300 watts. This is push-pull, and it's got two of those transistors in there. So that's how we're able to achieve 500 watts. Let's see if anything jumps out at us. Here again is the common source amplifier power gain at 30 megahertz, 50 volts. And the 50 volts is important too. For us to be able to operate in a clean way. And I remember reading an article by Rob Sherwood, and Rob is owns Sherwood Engineering. They've been around for 20 years or more, and he will evaluate in his lab all the transceivers, and he'll tell us, which transceivers, which has the highest sensitivity, selectivity, what noise floor. But I was reading that he said, the typical amateur is going to be satisfied with any of the top 20 transceivers. He said, there's really, because of the background noise, because, the operation, it really doesn't matter. And, not much to be gained working in that area. But he said, there could be improvements made in the transmitters. There's really not much. I mean, all the transmitters are compliant, with, meet compliance requirements, but they could be cleaned up. And he talked about, why our base stations, why are they based on 13.8 volts? Because that's part of the problem using those devices that are limited to 13.8 volts. If you jump to other devices and you operating around 50 volts, then you can clean things up quite a bit. And that's certainly important in the case here. The 50 volt supply.
Topic, USD, there was an article about the Clean Signal Initiative.
Right,
And you
right.
made a comment in there that tube amplifiers are more linear than solid state amplifiers, they're cleaner. Does that, this configuration address that discrepancy between solid state and tube amplifiers?
Is it more linear? I don't know. Yeah.
But we're going to run solid state stuff now, it could be both, like class B or class C, and then we filter at the end,
Mm-hmm.
because that's more efficient for transition.
Mm-hmm.
Running it with the linear part of the curve doesn't give you power.
Mm-hmm.
So I think that's one thing we're seeing. I can't get used to class C and class B amplifiers, but since
How does that work for linear signal?
it doesn't, but it gives you the chock bunch of stuff, and then you run it through a filter and smooth it out.
Mm-hmm.
I think they were talking about modulation distortion too, but. I don't really know.
And it makes pretty noisy stuff.
Yeah.
Yeah.
But I think the point with the article was there would be a working committee created to take a look at see what to motivate maybe some of the manufacturers to in what paths they might take to clean up and improve the spectral purity of the transmit signal.
So they're turning the spikes. You're gonna smooth them out.
If you still have a tube amplifier following your solid state transceiver.
Yeah, but if you mess things up by having a solid state. These little chips that do solid state oscillation. Those are turning on spikes. So you gotta figure out how to turn that into a design, and then put it in.
So any other questions about the amplifier?
Why not use 150 volt power supply?
Packaging. I'm sure he did that for, to be able to package them. It could have been an external 50 volt power supply.
Well, yeah, we, he's looking at, PBX article on amplifier that facilities can build. You all know about the building.
Mhm.
Tuesdays. And build stuff and sits around and talk about how we like it. And he's looking at that, and that usually is a separate 50 volt power.
Yeah, that would be an interesting project for.
This amplifier use ALC at all from the transmitter.
No.
They
Well,
also made a comment that the ALC is pretty much useless.
yeah, I've never used it myself. Just-
The displays on the front, is that part of the Arduino or Raspberry Pi?
Arduino, the Arduino, yeah, that's all part of the Arduino board, and that's all pre-assembled and pre-tested.
So your little console you showed the other day, was using Raspberry Pi.
Yeah.
This is controlled by
Arduino, that's right.
Get the two together and somehow use this stick hands.
Actually, this is the controller is not talking to this. The controller talks to the Hermes Light 2 transceiver. So to get to the next point was Tom's question, along the lines of Tom's question. How is it possible that I'm possessing and operating a amplifier that Kenwood or ICOM or Yaesu could never get type acceptance for? And it related to the Code of Federal Regulations 97.315, the certification of external RF amplifiers. And it comes down to the rules, and I've got it up here for us to see that no amplifier capable of operation below 144 megahertz may be constructed or modified by a non-amateur service licensee without a grant certification from the FCC. The requirement does not, the requirement of paragraph A does not apply if one of the more following conditions are met. And if the amplifier is constructed or modified by an amateur radio operator for use at an amateur radio station. So. Yeah, it's our license. We're covered by our license, and by our application, we're going to be using that. But what stands out, the amplifier? They didn't say all amplifiers. So individuals shouldn't be binge building amplifiers. That would probably draw some attention, but to explore the art, communications, and electronics, and amplifier and different amplifier technology, we're certainly allowed to build them and put them on air. Still need to be compliant. You still can't tear up the band, but you're allowed to build them. And I would be able to sell it too. I can sell that to another amateur, because we can read further. The amplifier is sold to an amateur radio operator or to a dealer. The amplifier is purchased in used condition by the dealer, or the amplifier is sold to an amateur radio operator for use at that operator station. So we can both possess it and we could pass it on to the next amateur that is interested in operating it. So I don't have any type, to answer your question, I don't have to go through any type acceptance or certification. No, it's best, you can look at it a couple of different ways, best practice. So you see the application of the devices, the MOSFETs, you're following the data sheet, how you apply it. You see you've got a robust low pass filter, just looking at that filter, you can say that's some pretty serious low pass filter. Also, you can look at it with a spectrum analyzer and looking at the third harmonic, needs to be 60 dB down. So if you there are things you can do, to feel relatively comfortable. Get on the local net, 80-meter net, and talk to guys that know your voice, and they'll tell you. So it sounds. Yeah. Yeah. Well, it was some of the guys. Yeah, some of the guys, like our friend Terry in N4CFM. He's got one of the Anon 7000 DLEs. He's got a 42-inch monitor, and he's watching everybody. He'll spread that thing out right on the signals, and he'll tell you who's stepping over the line. We're on 38, 58, and who's already up to 38, 62. Yeah. So any questions? Any questions about the? Yeah, I'm not an expert on this, but anything, I'm just really sharing my experience, sharing my experience and what I've learned or what I've observed about the build, and hopefully it's interesting. Hopefully it might help some of you. Be interested to see if you pull the trigger and build the 300 watt amplifier.
What's the total investment you have in this now?
The basic amplifier, the support kit is 1,200, and the RF power tools board is 500 with the transistors. The transistors, I looked at Newark or Mauser, and they're $165 a piece for the transistor.
Amazing on that, those transistors in that power.
Yeah. Yeah, he did come out with a tuner. So it wasn't available when I bought this. My antennas are resonant, and so I wasn't looking at that, but he's got a tuner kit available for it now. Mm-hmm.
If you turn that on with no antenna hooked up, it'll protect itself.
It's got some pretty fast protection, but I don't take any chances. Not at $165 a pop. Yeah, and I do mean pops. Yeah.
No, seriously, you turn it, would it protect itself if you forgot that your antenna?
Yeah, it's got protection, but because that's really important. That's really important with these with this type technology. Is you don't want to abuse it.
70 to 1.
But maybe only at 10 watts, very low power. I wouldn't push it.
Thank you, Darrell.
Yeah, all right, good. Thank you. Appreciate your attention.
Well, how much do you think you have for both the
Yeah, yeah. No, it was an enjoyable build. It was no hassle, well documented. You can come up and take a look at the books and see the operator manual and see the assembly manual. And they really were intentional about guiding you through the wiring harness for the power supplies. You'll make sure that you didn't get crossed up there. You know, it's you're winding the toroids, so you know, I probably 3 or 4 evenings, 4 or 5 evenings. You know, I never really I do, you know, step by step. So I really, you know, it's not a 40-hour kit. It's it might be 16 or 20 hours, something like that in building it. It's
Is it set up so you can test it each step of the way?
no, he doesn't, he's not gone into that. No, I don't recall. Yeah, you get one mess of yeah. No. Yes, well, you know, I have a 500-watt load and I have, I may have just used my HP generator and put a signal in there, and I really control that down to just a few dB of gain, you know, so very, very low gain. So I just eased into it, but it's not really much there. When you come up and take a look at it, it's not much to go wrong. It's not that complex. It's just, like I said, it's just those two MOSFETs and a few passive devices. And as long as you keep the power supply connected right, get that, then you'll be okay. All right. Okay, thanks a lot.
Yay, thank you. Great presentation.